Welcome all. Myself, Professor Vikram Singh Bias, SPM Polytechnic, Kumte Mechanical Department. Electron beam machining, that is EBM. Now today we'll see non-conventional machining processes, that is one type of electron beam machining processes. Electron beam machining is a thermal process used for metal removal during the machining process. In the electrical beam machining, electrical energy is used to generate the electrons with high energy. In the electron beam machining process, a high velocity focused beam of electrons are used to remove the metal from the workpiece. These electrons are traveling at half the velocity of light, that is 1.6 multiplied by 10 raised to 8 meter per second. This process is best suited for micro cutting of the material. Basic principle: when the high velocity beam of electrons strikes the workpiece, its kinetic energy is converted into heat. This concentrated heat raises the temperature of workpiece material and vaporizes a small amount of it, resulting in the removal of the metal from the workpiece. Construction working of the electric beam machine. Basic parts of this particular machine. The schematic diagram shows it consists of an electron gun, diaphragm, focusing lens, deflector coil, work table. To avoid collision of accelerated electrons with air molecules, a vacuum is required, so the entire EBM setup is enclosed in a vacuum chamber, which carries a vacuum of the order 10 to 5 to IO2 6 mm of mercury. This chamber carries a door through which the workpiece is placed over the table. The door is then closed and sealed. The electron gun is responsible for the emission of the electrons, which consist of the following three main parts, that is tungsten filament, grid cup, anode. Working of electron beam machining. When the high voltage DC source is given to the electron gun, tungsten filament wire gets heated and the temperature rises up to 2500 degrees centigrade. Due to this high temperature, electrons are emitted from the tungsten filament. The electrons are directed by a grid cup to travel towards downwards, and they are attracted by the anode. The electrons passing through the anode are accelerated to achieve high velocity as half the velocity of light, that is 1.6 multiplied by 10 raised to 8 meter per second, by applying 50 to 200 kilovolt at the anode. The high velocity of these electrons are maintained until they strike the workpiece. It becomes possible because the electrons travel through the vacuum. This high velocity electron beam, after leaving the anode, passes through the tungsten diaphragm and then through the electromagnetic focusing lens. Focusing lenses are used to focus the electron beam on the desired spot of the workpiece. When the electron beam impacts on the workpiece surface, the kinetic energy of high velocity electrons is immediately converted into the heat energy. This high intensity heat melts and vaporizes the work material at the spot of the beam impact. Since the power density is very high, about 6500 billion watt per millimeter square, it takes a few microseconds to melt and vaporize the material on that particular impact. This process is carried out in a repeated pulses of short duration. The pulse frequency may ranges from 1 to 16,000 Hz. The pulse frequency may ranges from 1 to 16,000 Hz, and duration may ranges from 4 to 65,000 microseconds. By alternatingly focusing and turning of the electron beam, the cutting process can be continued as long as it is needed. A suitable viewing device is always incorporated with the machine so it becomes easy for the operator to observe the process of the machining operation. Machining outside the vacuum chamber. Since the fully vacuum system is more costly, the recent development has made it possible to machine outside the vacuum chamber. In this arrangement, the necessary vacuum is maintained within the electron gun and these gases are removed as soon as they enter into the. धन्यवाद.